Good morning to all. Welcome to today's webinar, which is the second edition of our Wind Energy Academy Latvia. It's a pleasure to see you all here. And as usually, my name is Lasma Līvzniece. I'm the Executive Director of the Latvian Wind Energy Association. And today we will look at the second step of the whole wind energy development process in Latvia, which you probably joined in the webinar that we hosted last time. And today we will specifically look on how to find appropriate area for wind farm development. And more specifically, we would like to tell you what are the main pitfalls or the main errors wind farm developers potentially can make, and we would like you to avoid them. And with me today will be Renārs Urbanovičs from Utilitas, who's actually the icebreaker in the Latvian market, if I may say so. He commissioned the wind farm last year in Targale, and he has gone through all these steps and has this practical experience. And we're very happy that he's agreed to share his knowledge and experience yet again. So before I give floor to Renārs, I would like to explain a couple of housekeeping rules. So we will have a presentation by Renārs for approximately 30 minutes. After that, we will have a Q&A session, and you are able to ask your question in the chat section. We will see the questions and then ask those questions to Renārs after the presentation. Okay, that's it from my side, and I would like to give floor to Renārs now with the top 5 pitfalls to avoid when planning the timing and location of wind farm in Latvia. Thank you, and Renārs, please go ahead.
Good morning, ladies and gentlemen. Very warm welcome to our next installment of webinars organized by Latvian Wind Energy Association. My name is Renārs Urbanovičs. I'm council member of the association, and I'm really delighted to be here today to share some insights into planning processes which might at some point perhaps be considered trivial, but at the same time they have quite a lot of importance in long-term planning of wind farm development in Latvia. Some national peculiarities, some regulatory challenges, and so forth and so forth. I'm pretty much sure anyone working on these issues or planning to do some wind farm development in Latvia will find this interesting enough to follow through. Will be brief. I'm sure we'll not extend our presentation more than half an hour. And once again, very warm welcome, and let's move on to our first items. So, speaking about overall design, construction, and installation process of wind farms in Latvia, we have to bear in mind that design and engineering is a distinctly separate section of the whole process from a regulatory perspective, and it's not something that can be done in parallel to actual construction. So from the point of view, if you are looking at this type of activity as design and build, it's definitely design first and build later on. So some items which are essential to bear in mind are directly related to design and engineering phase. Now, once this is complete and you have full set of construction permits, you can move on to actual construction process, and that's the second area of topics to consider. And finally, deliveries, installation of turbines and components. That's something that completes the whole process and is also quite important in this whole chain of development. So now let's move on to design and engineering. When talking about a balance of plant design in national settings, there are at least four topics which I would like to discuss here, and they are not ranked in some particular order. Rather, they are related to different types of activities or different types of designs works you are carrying out in this initial phase. And well, let's go through all of them. Now, topic number one: placement of cable arrays within existing public roads. Latvia has a very defined regulation for land plots, and well, the area of any development is pretty much limited to those areas where some contractual relationship with landowners is established. So effectively, this means that one cannot really impose any of its construction activities onto land or some land plots which are not directly under some kind of commercial or administrative relationship between the developer and the landowner. So public roads is one of, let's say, best opportunities to use existing public land for placing infrastructure, like using these roads for development, and at the same time using the area of these land plots also to install power cables, optical network, and so forth. So the question is how to use it wisely. Now, second topic is in relation to geological investigation, which is a really crucial piece of information for foundation design. The third one, well, based on the information from these geological investigations, it's also important to take a look at what are, well, typically most available piling solutions to be used and what are their cost effectivenesses. And finally, sometimes quite an overlooked topic is availability of external secondary grid connection for, well, wind farm once it is in operation. I'll try to cover all these topics in several slides, and let's move to the first one in relation to placement of power cables on public roads. From the permitting point of view, it's not really difficult to obtain the relevant permits from owners of public roads. Well, typically you would find two authorities or two types of authorities in charge of these road land plots. First, it's municipalities. This is mostly in relation to gravel roads or some sections of paved roads in rural municipalities. Well, and second option, of course, is Latvian State Road Authority, which is in control of most highways and also some regional roads, also some of them being unpaved gravel roads. And to be honest, from actual experience of developers, we can presume pretty much that it's much easier to deal with municipalities than Latvian State Road Authority due to of course, the importance of these roads in the overall road network. And one, I guess it's pretty much clear is that using a type road, road of national importance, to place cabling alongside the road is always should be something that is much more difficult to manage. But then again, it's not really impossible. It's all about meeting the regulations. Now, and when talking about the way how it's to be done, you should always carry in mind the clear understanding that on top of placing cables within the area of the road land plot, ideally you would like to avoid the area of the road itself. So any ditches, any areas next to the road mostly are fine. But then again, also please note that it's important to also pay attention to the protection zone around the cable itself, which according to the legislation, current legislation, extends at least 1 meter in either direction around the cables. And this is something that also should not extend onto the adjacent land plots, and ideally you should try to fit everything within the same land plot, including the protection area around the cables as well. So looking at an example, you can see clearly that that's something that one should also keep track of to make sure that not only the cable itself stays within the land plot area, but also the protection zone itself is always met. Well, in those cases when you are not able to, this would directly lead to a request from the municipal construction board to get confirmation for such placement also from the adjacent neighboring land plots on the other side of the border area between these land plots. So this sometimes is something that you would most probably be able to do. In some cases that would be a challenge, and therefore to avoid this, if you are able to still place everything, including the protection zone, within the same road land plot area, good for you. From the technical perspective, most probably the cross sections of underground cables you would place within the land plots would be quite different depending on how many cables you would expect to see there. So if it's just connection for 1 or 2 turbines, most probably you will end up with one cable. But then again, if entire bunch of cables is close to the substation you are planning to connect to the grid, most likely you will have 3, 4, 5 cables going parallel. So in that case, the whole cross section, the layout of these cross sections is something to consider as well. It will make all things a bit more complicated, as you would have to squeeze much higher number of cables within the same area. So this is something of even more importance in those areas where you are approaching your grid connection points. So please bear that in mind. And once again, it's all about combination of optimal design and also permitting. So if you are able to do optimal design and stay within the same land plot, great. If not, it's also getting permits from your neighbors to make sure that it's something they are comfortable with. Now, let's move to the second topic, geological investigations. Latvian geological conditions are quite distinct in a way that there is a great variability in what you would find underground. The soil itself, composition of different layers of soil up to the depths which are able to sustain high levels of bearing capacity may vary quite a lot even for the same site. This is especially true for areas which are located close to coast. And in order to, of course, to assess properly how suitable particular points for wind turbine placement are, standard cone penetration test would be required to see actual site conditions. And what you would find, here is an example of just one site which stretches 7 to 7 kilometers across, and one of the turbine locations would have soils with sufficient bearing capacity already at some 11-12 meters, as in this CPT test result shown on screen. In some cases, you would find most probably, on the same site, something that goes down to 24, 25 meters, which might be challenging from the point of view of piling solutions. We'll talk about that later on. But then again, do not take it for granted that your geological conditions will be uniform and similar across the whole site. And recommendation on this is to really to look into this as earlier as possible to establish what in general you would expect there by doing 3, 4, 5 CPTs in different locations and learning of general situation under the ground, which you are normally not able to see. And of course, in order to prepare the final design of foundations, of course, always you would need much more detailed CPTs and boreholes for each location. But this is something you would eventually, of course, do once your micrositing is completed and you are at least ready to move into the confirmation of these exact spots from the point of view of permitting. Because anyway, carrying out geological investigation, which is not later on supported by actual construction on the same spot, is, essentially a waste of money. But now, once you have learned about this, the conditions under the ground, it's the next question is what to do with piling. As we saw, there are a wide range of options or other challenges you would find from the soil perspective on a typical site, and therefore most probably you would have to also be quite flexible in your foundation design. So conditions, depending on your geographical location in Latvia, would vary from plain gravity foundation to using really deep piles which would extend more than 25 meters. It's of course unfortunate that you would run into a site where you would have to have 25, 30 meter long piles, but it's something that cannot be avoided. In some areas, it's simply the result of geological formation across the ice age, and I will not be going into these details how it came along, but it's something that one should really be aware of and take into consideration already at the design stage. Now, let me show you also an example of another topic which also comes directly from geological investigation. So let's compare two CPTs for two different locations. Here on the left you would see a situation when there is essentially no soil resistance up until the point when bearing capacity of some layers underneath are sufficient enough to support the whole piling structure. And on the right you would see that in this case the upper layer of soil, while it's not ideal, while it's not able to really support a lot of bearing capacity, it still provides a lot of resistance. So this means essentially that for the left-hand solution, or rather left-hand situation, you would have to develop a piling solution which would be based only on compression forces. So when you're placing a pile, you would have to rely that there is no resistance alongside its sides, and the pile head itself would have to rest on the soil layer with a high bearing capacity. While on the right-hand side, it's obvious that you still are able to use some of the friction force which would come out of the upper layers of soil, and in that case it would not be only compression forces but also tension forces. The second case is much more preferable in terms of your foundation design, as this means less need for materials, and essentially this is also something that drives down the costs of foundation construction process. But then again, of course, the unfortunate downside of all of this is it's something which is beyond your direct control. In most cases, you would be just presented CPTs, and well, if you are lucky enough, hope is that you will be in those positions where you, ideally are dealing with gravity foundations, but if not, then at least the combination of tension and compression forces. So this is something to look at in your initial design stages, and at least if you are able to select locations where there are more favorable geological conditions, please do so. Another topic in relation to piles, if you have to go for the piles, then it's selection of precast or in-situ piles. So whether it's something you would bring from a factory, which always guarantees better quality and less issues with installation, but then again, it's much noisier option, and not all locations are favorable for this type of piling, and also depth is an important element in all of this. In most cases, most probably you will have to settle for some piles which are made on the site, and once again, depending on your solutions, please take into consideration available machinery. CFA piling is something that is, from the machinery availability point of view, is the most common technology used throughout Baltics, and this is something you most probably would like to base your piling solution to make sure that you are not squeezed into a situation where some other technologies are a must from the design point of view, but you are not able to work out machinery solutions for that. But then again, if machinery is available, it's something that is definitely to look into and consider as a viable option. And now finally, the fourth topic on the BOP design issues is secondary grid connection. It's, as I mentioned previously, it's quite often overlooked, but please think about that. Generally, TSO requires certain maintenance procedures on their side of the grid connection, on the substation that has been put into operation once your wind farm is up and running. And this is something that they are routinely doing, using their own resources and their own planning. And typically you would encounter at least 5 to 7 working days which have to be devoted for a almost complete shutdown on the TSO side for the first year of operations, and roughly half of that in subsequent years. So which effectively mean, of course, not all of these shutdowns are scheduled in a way that it's just extends for Monday to Friday. It's couple of days and at once typically, but it could be also going on for even 5 days in some cases. To make sure that the whole equipment and all turbines are still in operational condition, they are still connected to the grid. A suggestion is to consider to have a secondary grid connection, typically connected to medium voltage network, which would not be used throughout, let's say, typical day of a year, but which would be there for these emergency shutdowns on the TSO side. So in that case, having this connection itself would power medium voltage operations of your wind farm throughout this shutdown period. So that would effectively be a backup for being able still to have these turbines connected to the grid, of course, they would have to be shut down, as you are not supposed really to essentially to connect your wind farm and to operate it through this medium voltage connection. But then again, all the consumption of different elements, both of the substation and also turbines, well, in a way, self-consumption of energy throughout this process, something that you should be able to handle well, during these periods of shutdown from the TSO side. This, of course, will make your well, restart of the whole wind farm much easier later on. It's not a, let's say, critical item, but then again, if well, you are disconnected, the wind farm is disconnected for, well, more than 5 days, most probably you will have to face at least, well, 1 more day or 2 more days until you bring all your turbines up and running, simply because all the internal backup power has been already used, and well, turbines themselves have gone into a cold shutdown. So it's a business decision just to put well, onto different sides of well, onto different sides of the scale, what is essentially the cost of this secondary connection, and to potential revenue lost while not being able to come back online on time. The good news is that now we are done with design and engineering. Now we are ready to move into construction. Now, topics to look at when planning these activities on the ground, and well, once again, there are several items which should be really considered throughout your construction progress. First of all, deforestation. Now, according to Latvian regulations, there is a general curtailment of any deforestation activities, and this is related to the protection of nesting of birds throughout April 1st of April to end of June. So essentially 3 months, it's a period where you are not able to plan any cutting down any trees, and as well, this is something that would also impact your construction schedule if you are planning to use the same area later on for road construction or turbine foundation construction. So please try to avoid any scheduling your deforestation activities in the Q2 of each calendar year. Well, a similar issue coming from weather conditions is there for road usage. Now, it typically starts in late February and lasts until beginning of April, when well, snow is melting down, if there is any snow. But as a result, soil conditions become so wet that most of gravel roads are not really usable. And even if they are, road operators, including municipalities or Latvian state roads, they are prohibiting using these roads for heavy cargo transportation. And this relates not only to component deliveries, but also to any construction material deliveries from the time when this period of the year is setting in, and as I said, it's from end of February to beginning of April. It varies from year to year based on actual weather conditions in a particular year. But then again, I'd say 1 month of construction is something you will not be able to do due to these weather conditions. Now, when we are talking about weather, Latvian weather is also quite notorious for being relatively wet from November to March. It's not really a wet season as in some tropical countries, but yet the issue with excess water levels and ground levels is so complicated that it's something that would essentially turn your piling works into quite a mud challenge. If you are able to plan your piling activities, please try to do this in spring and summer seasons and try to wrap everything up until end of October. It's not impossible, but it's really challenging to do this later on into late autumn or in winter. There might be instances, there might be some particular weather conditions when ground has frozen. It's really easy to work on top of it. But then again, if that is the case, most probably low temperatures will be also challenging for running machinery at -10 or -15 Celsius continuously. So it's another issue to consider. And if we are also considering some biological diversity issues, if your BOP design calls for reconstruction or construction of some new bridges, please bear in mind that due to fish breeding season, which starts mid-April and ends around mid-June, or to protect some migratory fish species from beginning of October to middle of November, you are generally not allowed to carry out any activities on the banks of rivers, anything that would pollute water with any dust, sand, or anything else which would somehow impact fish population in that particular river. Of course, this is not a typical case when you would have to construct any bridge. But then again, if that's part of your plan, please take into consideration that eventually this might challenge you at some point. And finally, this is more or less technological issue. Turbine energization. When setting your schedules for turbine delivery installation, please remember that during the commissioning phase, you would have to have power supplied to turbines. Of course, all turbine manufacturers are ready to use power generators to do that. But then again, if your BOP construction on the grid connection point is not up to the task and you are late with that, most probably you will end up in lost revenue later on, and it will be really, really challenging to commission the turbines that have been installed. So this is something to also think in advance and always push your grid connection to be first in terms of installation compared to turbines which would be installed later on. And if we are now switching on to this happy phase of turbine components starting to roll into your site, then once again, there are 2 points I would like to point out here regarding deliveries. So adverse weather conditions, and essentially we are talking here about relatively high wind speeds, which might be a challenge for crane operations during installation. It's something you would typically find from October to March. And of course, if your wind farm is of relatively small size, this is something you'd most probably be much easier for you to deal with, as you would encounter still some periods of low wind when cranes might carry out their activities. But then again, if we are talking about really large wind farms of 15, 20, 25 turbines, that's something to really consider, whether it's worth challenging than expected in the way of high winds, which are much easier to deal with starting April, summer months, and so forth, because you will simply rack up standby costs from crane operators, from installation teams, and so forth. But then again, there might be some economic reasons why you would like to do that. But at the same time, please bear in mind that the bill for standby periods will be quite extensive. And second, and this is a red light, green light type of challenge, is similar to what I mentioned when talking about BOP construction. Gravel roads are essentially quite difficult. Well, they are not even quite difficult. They are even not permitted for transportation, typically from end of February to middle of April. Once again, this depends on a calendar year, on actual weather conditions during that year. But it's safer to assume that, this limitation will be in any given year, and plan your turbine component deliveries accordingly. Just stay on the safe side. This now brings us to the end of the topics we wanted to bring to your attention today. And essentially this covers the most challenging aspects in planning process of wind farms in Latvian conditions. I hope this is something that you will put into a good use. And in any case, from association with Love, we very much appreciate you being here today with us. Thanks for listening in. We'll have some questions, I suppose, later on, which we'll try to address. But in any case,
Thank you, Renārs. Yes, I think we can bring Renārs on the screen as well. Now I was just gonna make a little joke that while we're lecturing him about how not to make errors in wind farm planning, errors happen on the technical part of this webinar. But never mind. So thanks for staying with us during this presentation, and we now have the Q&A session, and let's go through some questions. There's a question in the chat, but before we get to the questions, once again, so the video will be available on the LWEA, so the association's website and social media, and then the presentation will be sent to everybody who registered. And if you didn't manage to register because the registration was closed this morning, so do send an email to me, to the association, and I will make sure that you receive the presentation. And so there's a question that came in via email. Somebody is asking about the backup line or the backup connection that a developer must do. Can you elaborate a little bit more on that? Is it another TSO connection, or what is it?
Well, that's a good question. Well, in fact, it's not such a must. It's not really a must to have the secondary connection as a backup. It's rather a wishful thinking, which might come handy in some specific situations later on when the main grid connection is off due to maintenance reasons. So it's always good to have a limited small connection on the medium voltage side as well, which could be switched on, which is not used on permanent basis, of course. But then again, when you are off the main grid connection, that would help all the auxiliary systems to function properly within the substation. You would still have your security cameras on, you would still have all other equipment up and running, so you would not be cut off the world without any life support, if I may say so. So that's something that provides much better operation conditions for the whole wind farm and also substation later on during its lifetime.
Thank you. The other question is on the main lessons learned with respect to the environmental impact assessment and the technical requirements for environmental protection. So is there any valuable tips to tell to our listeners?
Well, I believe that in this case, the recommendations, in this particular case, is just follow the formal procedures set forth by environmental authorities. Well, to some extent, I must admit that they are quite numerous in Latvian conditions. You would have at least 3 authorities to deal with on different levels and different types of questions to be addressed. From the state bureau overseeing the whole environmental impact assessment procedure down to environmental authority dealing with day-to-day issues and technical regulations for your development, and finally, nature protection authority, which is in control of monitoring processes and which collects and analyzes your activities post-construction in terms of environmental impact and so forth. So it's not an easy picture to navigate, and each of them has their own priorities and their own favorite topics to always to bring into the play. And it's I guess the most reasonable approach, and this has been tested in practice. Be honest, be open about your intentions, provide reasonable information in all development stages, and this will definitely pay off during the development phase. But then again, once you are up and running, please follow the regulations issued to the letter in most cases, and try to it's not something I would suggest to treat as offense, but then again, people you are dealing with on environmental front are typically they are state they are representing states. They are bound by their internal framework of decision making and so forth, and they are limited with the options they have. Even they fully understand in some cases that some of the requirements may be out of context and not really applicable. Still, they are not in a position to change them, and most probably you would have to adapt to some degree to these requirements, even if they sound unreasonable. So never expect your way will be the right way.
Right, thanks. On the same note, there's a question on environment, or somewhat environment, because you spoke about deforestations and the months when it's prohibited. What about a few trees along the road? Would the limitation apply to them as well if you wanted to chop them down in the same?
In this case, no, it's not the same type of limitation which would apply to standalone trees in some other areas outside forest areas. But then again, that's a different set of regulations which requires different type of permitting, and in most cases you would have to deal with municipalities and their respective either construction board or some other internal body which deals with this type of permitting. But then again, it's case by case basis, and it's rather not the timing of when cutting down these trees can take place, but rather whether it's allowed or not allowed given certain conditions in general. So most probably nobody would really expect some of the trees which are, in case you need to transport some components through the center of Riga city, nobody will really be happy to cut down any trees along the way. So it's some decisions which are based in wider context.
Right. And a question on geology. How many boreholes would you recommend to make for a, say, 150 megawatt wind farm?
Well, if we are talking about the first phase, let's say preliminary phase to investigate overall geological conditions, in that case, well, I'd say rule of thumb is not really in relation to megawatts, but rather if you look at your layout and you are able to pinpoint certain, let's say, clusters of turbines here and there, it would make safe assumption, to make at least one CPT for each of these clusters, simply understand the surrounding geology, because as I mentioned during presentations, these conditions may vary to quite a degree across the whole area. But then again, if we are moving to like full geological investigation, in order to obtain information as input for foundation design, well, that's once again, you would have to have 3 CPTs and at least 1 borehole on each location per each turbine. So it's something you will never be able to avoid to make sure that your foundation design is safe.
Okay, thank you. And then we've got a question on permits and the lengthy process. So how swift has the process of getting all relevant permits for the use of roads for transporting oversized wind power plant elements been? Any particular difficulties encountered?
I'd say this is a 3-stage process with 2 sets of permits. So first of all, it's about basically identifying a route which is you are able to take with these components based on their lengths, on the dimensions of the transport delivering those components. Advice is to make the route survey and make sure that from the point of view of professional transportation company, this is something you can really travel. Once you have identified the route, the first is the next item on the to-do list is to describe the whole route in a reasonable manner, identify those sections where you need to make sure there is a need for alterations, cutting down trees, removing some poles, extending road surface, and so forth, and carry out the necessary preparatory work. And at the same time, and make an application to Latvian state authority, which would approve the route itself. It's not about issuing a permit you to travel the route, but rather accepting the route as something that can be used. And finally, once you are ready for the actual transportation, you can list exact timing of this transportation, be it just 1 day, or most probably if you are doing a wind farm, it will be several days. You just submit separate permits for each case of transportation in order to make sure that eventually you are escorted by police cars and so forth. There is a separate set of regulations about that, and each case is then sort of permitted separately. So do your homework, understand the way you would like to travel. Second, get permitted the same route which you discovered as usable, and then apply for each instance of transportation separately to comply with road safety regulations.
Thank you. And then another question on the transportation. And it's more specifically on how do you handle low-hanging cables during the transportation of wind turbines to the site? And is it easy to get permission to raise or reroute the cable, or how should this be handled?
Well, in each case, you would have to contact the owner of that respective cable line. So it's something where you would need to come up with a solution, a temporary solution, how to do that. In some cases, when it involves putting up some additional structures, you might even get to a point where you have to carry out a separate temporary construction process in well, as you would do with any construction. In some cases, in some instances where it's not so difficult, it's just an agreement and a work execution plan you would agree with an owner of respective well, cable lines and communications. So cases are essentially different based on let's say on the extent to which you would have to do these modifications. I'd say, well, the most complicated case is when you have to travel through some underpass and you are physically limited by a bridge above your head, and in that case I'd say it's a no-go. You should most probably plan some alternative route, but cable lines, it's something that can be dealt with relative ease, but then again, extent of this depends on the technical solution which is needed in each instance.
Okay, now let's move back to geology, because we've got an interesting question here. So what would be the earliest moment to do the first on-site geological investigations and tests? So the earliest.
For preliminary investigation, I'd say, well, a reasonably good moment is to carry those out when you have a, well, quite positive feeling in your heart and stomach that your project is moving ahead. So it's not really the moment when you are still investigating this, whether it's feasible or not, but when you are really committing to your environmental impact assessment and because in this case, it's also provides some information also for decision making during environmental impact assessment as well. If you just discover that some of, well, a particular cluster of turbines is located in a really troublesome area from a geological point of view, this could help you in a way to get rid of it from the final well, permitted layout. In case if there are some other issues, you would not really fight with your teeth to make sure that it's included in the final layout if you are aware that it's sort of a bit tricky really to also execute well, foundation works later on. So it's please treat this as well as a reasonable input also for your final layout permitting as well, and do this well prior to that.
All right, and we have received a lot of thank you notes in the chat to you, Renārs, and I do agree with the people here that says that you've done an excellent job presenting the different errors that one could make and how to avoid them. So but yeah, there's just one more question that has come in terms of lands and cables, how the state-owned lands and how fast they are giving out the necessary permits. So yeah, so in terms of lands and cables, how the state-owned lands give out the permits. So how do you receive permits to state owned lands, I guess, and is this a fast procedure or does it take time, for example, compared to private plots, private landowners?
Well, then again, yeah, I guess I have to cover both areas of ownership here. So regarding land ownership, if we are talking about state authorities and municipal authorities, we really have to distinguish between those two, because from, well, practical experience, municipalities are much more responsive. So if you are able to identify an area which is suitable for your infrastructure needs, and it's owned by municipality, well, consider this to be a relatively good luck, because the whole process will be, well, relatively direct and straightforward, as long as you are able to, well, demonstrate your commitment and reasonable well, responsibility towards the landowner. Now, if we're talking about state-owned lands, this comes, well, in different types of ownership. So this is ranging from Latvian state forests down to Latvian state road authority, and, well, each case is treated separately, and I would expect that the whole procedure to get this fully permitted is quite, well, dependent on the level of formalization of formalities taken into well, the overall operational model of each respective company. They are following their own regulations, internal regulations, which may differ, which might change over time. So it takes much longer. I would expect this to range, well, from some 4 to 8 months on average. Even, well, they are sort of not objecting to the idea itself. It simply takes a lot of communication, well, letters, responses to letters, applications, sending in some designs and so forth in order to get this approved. So it's a bit more complex. And well, for the private ownership, well, it's I guess the easiest way to deal, but then again, it's something that, well, there is no rule book. Well, you just go out and see if you are on the same page with the landowner, and in that case, as soon as you have well, their consent, you are quite in a good status to proceed then with all the, well, design and implementation phase. But then again, if the owner says no, well, try your luck elsewhere.
I see. Okay. Thanks, Renārs, very much. And it's 12 o'clock Latvian time, and 1 hour has passed. And with this, we will conclude. I just wanted to thank you all for joining in. And yes, I mean, it's still, so if you find topics that are, am I still on? I hear music, but I just continue talking. So if you have any ideas of other topics you'd like to have us covered, please let us know. And yes, and just stay tuned. Let me know if you want to be on the LWS mailing list, and look forward or tune in for the next webinars we will organize. Thanks again. And with this, we conclude this webinar.
Well, just the final point. Merry Christmas, Happy New Year, and let's meet in some, well, next installments of our webinars. Thank you.
True. Happy New Year. Merry Christmas, Happy New Year.